Assalamualaikum and good day everyone. So today we are going to proceed with the last properties of Laplace transform, which is multiplying by Tn function. So before this, in my previous video, I already explained to you on how linearity properties and first shift properties works. Okay, so now let's take a look at these properties and when we are going to apply these properties. Okay, let's consider this one. Before this, if you have Laplace of ft, so this one is equals to fs. Okay. For first shift properties, if you have Laplace of exponent atft, then you will have fs minus a. Okay. So for multiplying by Tn function, you are going to apply these properties when you were asked to find the Laplace of multiplication of two functions and one of the function is t to the power of n. Okay, so Laplace of this one is equals to negative 1 over negative 1 power n dn over dsn fs. Okay, so this is the formula to find the Laplace of t to the power of n ft. Okay, so we apply these properties when one of the function is t to the power of n. Okay, and another one can be any other function. So if let's say you are given t squared exponent 2t, okay, if your ft is equals to this one, so you have two ways of doing it. Okay, the first one is by applying first shift properties, and the second one is by applying multiplying by Tn properties. Okay, multiplying by Tn function. Okay, so to use this one, it's involve differentiation, as you can see here. Okay, so how many times did you need to differentiate? It depends on your n. So where to get your n? Refer to the power of your t function. Okay, so if you ask me, if you have this kind of problem, which one is the easiest way to get the answer? My answer will be by using first shift properties. Okay, but actually you can use both properties to solve this kind of problem, because in first shift properties, one of the function must be an exponential function. So another function can be ft, can be any other function. So your ft is equals to t squared. If you are using multiplying by Tn properties, so one of the function must be t to the power of n, which is this one. So you know that your ft is equals to exponent 2t. Okay. So now let's try to solve this problem. The first one. Let's say you are given ft is equals to t cos t. Okay, so by referring to this general form, okay, you know that your ft is equals to cos t and your n is equals to 1. Okay, so first step is to define your n. Okay, define your n based on your given t. So as you can see here, this is t to the power of 1. So you know that your n is equals to 1, isn't it? Okay, so the next one is, what is your ft? So by comparing this one with the general of t power n ft, so you know that your ft is equals to cos t. Okay, so this is your ft. So your ft is equals to cos t. So get the Laplace of this one first. So Laplace of cos t is equals to s over s squared plus 1. If you still don't know how I get this one, please go back to my previous video. Okay, so now you have this one. So the next step is to substitute what you have here into this formula. Okay, so what you have here is Laplace of cos t. What you want to find is Laplace of t cos t. Therefore, Laplace of t cos t is equals to, so take a look at this one, negative 1 to the power of n. So you will have negative 1, your n is equals to 1. Okay, d ds, since your n is equals to 1, fs. So what is your fs here? So this is your fs. Okay, so your fs is equals to s over s squared plus 1. Okay, this is not yet the final answer. Why? Because you have an operation here which is d ds s over s squared plus 1. So what you need to do is differentiate this one first, then substitute back into here, multiply by negative 1. Therefore, you will have the answer for the Laplace of t cos t. Okay, so how are you going to differentiate this one? D ds of s over s squared plus 1 is equals to, so this one u over v, so you have to apply quotient rule. Okay, so you will have v du minus u dv over v squared. Okay, so you just expand and simplify numerator part only. Okay, for denominator part, just leave it as this one. It's okay. Okay, so expand and simplify this one will give you s squared plus 1 minus 2s squared over s squared plus 1 the whole thing squared. So therefore you will have negative s squared plus 1 over s squared plus 1 the whole thing squared. Okay, so this one is the answer for this part. Okay, so the last one is, so your answer for Laplace of t cos t is equals to, so you have to substitute this function back into here. Okay, so you will have Laplace of t cos t is equals to negative 1 multiplied by this function, negative s squared plus 1 over s squared plus 1 the whole thing squared. Okay, so therefore your last answer, so expand this one will give you s squared minus 1 over s squared plus 1 the whole thing squared. So this is the final answer. Okay, so this is how you apply multiplying by tn function. Okay, so let's recall back. So the first step is you have to know when you need to apply these properties. Okay, you apply these properties if you were asked to find the Laplace of a multiplication of two functions and one of the function must be t to the power of n. Okay, so if it satisfied this condition, then you can apply these properties. Okay, so ft here can be any other function. Okay, so in this case, for this example, you know that your ft is equals to cos t by comparing this one with the general one here. Okay, so you know that your ft is equals to t cos t and your n is equals to 1. Where did I get this value? Is from your t here. The power is 1. Okay, so the next step is to get the Laplace of the ft first. So Laplace of cos t, so this one is directly from the table. Okay, from the table of Laplace transform, so you will have s over s squared plus 1. Okay, so the next step is, okay, this is Laplace of cos t. What you need is Laplace of t cos t. So by using this formula, you know that your Laplace t cos t is equals to negative 1 power n. So your n is equals to 1, so you will have negative 1 here. dn dsn, since your n is equals to 1, then you will have d over ds of your fs. So where did I get my fs? Is from here. Remember that the Laplace of ft is equals to fs. Okay, so Laplace of cos t ni is actually your fs. Okay, so for this part here, you need to differentiate, but remember, since this is s over s squared plus 1, so you have to apply quotient rule. Okay, so let the whole thing here, denominator is your v and this is u, so applying quotient rule will give you this one. Okay, so expand and simplify the numerator part only, which is the up function here. Okay, numerator part only. So expand and simplify, so therefore you have this function. Okay, so now substitute back this one into this equation, so it will give you the Laplace of t cos t is equals to, so negative 1 times the whole function here. Okay, so you will have s squared minus 1 over s squared plus 1 the whole thing squared. Okay, so now let's take a look at another example. Okay, so let's say you were asked to find the Laplace of this function. ft is equals to t squared exponent 3t. Okay, remember, when you have this kind of function, you can either use first shift properties and also multiply it by tn. Okay, but since I am now explaining this topic, so I will apply multiplying by tn function. Okay, so by comparing this one to the general one of Laplace of tn ft is equals to negative 1 power n dn dsn f of your fs. So by comparing this one with what you have, okay, t squared exponent 3t, okay, so you know that your n is equals to 2 and your ft is equals to exponent 3t. So get the Laplace of this one. So Laplace of exponent 3t is equals to 1 over s minus 3. Okay, so this is your fs. Okay, remember, when you have ft, I already explained this one in the first video for Laplace transform. From ft, so apply Laplace transform, then you will get fs. Okay, so now Laplace of exponent 3t is equals to 1 over s minus 3. But what you need is Laplace of t squared exponent 3t. So this one is equals to negative 1, since your n is equals to 2, d2 ds squared of your fs. So what does this mean? This one. What is the difference between the previous example? You have d over ds, but here you have d squared ds squared. So this one, you need to differentiate twice. Okay, why twice? Because you have here 2. Okay, so you need to differentiate twice. Okay, but for this one, you just differentiate once, then you stop. Okay, so how many times you need to differentiate? It depends on the power of t. Okay, which is your n. What is the value of n? Okay, so now try to differentiate. This one will give you, okay, your dds. So the first step is get Try to differentiate the first one, d ds of 1 over s minus 3. Okay, this one you can either use product rule or also quotient rule. Why? If you bring this function to the front, to the numerator part, so you will have s minus 3 power negative 1. So use power rule to get the answer, or just use quotient rule. Okay, so let this one as your u and the denominator part as your v. Okay, so I'm using quotient rule. Okay, so you know that your ds of the first function 1 over s minus 3 is equals to v u prime minus u v prime over v squared. So you have s minus 3 squared. So therefore your answer is negative 1 over s minus 3 squared. Okay, but this is ds. Okay, so you remember that you need to differentiate the function twice. So differentiate again will give you, so the second differentiation will be this one, ds of this function, negative 1 over s minus 3 squared. Okay, will give you, so it's either you factorize the negative first because negative is a constant. So v u prime minus u v prime. How to differentiate this one? Bring the power to the front, so you will have 2 s minus 3. So power here reduced by 1, and different, so you will have 1 here. And the next one is to differentiate inside here. So differentiate s minus 3 will give you 1 over v squared. So you will have s minus 3 power 4. Okay, so this one times by 0, so you can cancel out this one. So negative negative will give you positive. So 2 s minus 3 over s minus 3 power 4. So as you can see here, you can simplify this part. So you left with 2 over s minus 3 cube. Okay, because this one is 4, so cancel out, then you left with 3. But this is not yet the answer. Okay, so substitute what you have here back into, back into the formula. Okay, so therefore the Laplace of t squared exponent 3t is equals to negative 1 squared times this function 2 over s minus 3 cube. Since this one will become positive, so you will end up with the same answer. Okay, 2 over s minus 3 cube. Okay, that's it. Okay, so if you ask me which one is simple, which properties is simple to solve this kind of problem, my answer is first shift. Okay, so just try to do the same function here, but try to solve by using first shift properties. You will end up with the same answer. Okay, so try on your own. Okay, so let's take a look at the last example, which is this one. Let's say you have your ft is equals to t squared sine 2t. So you know that your n is equals to 1. Okay, your n is equals to 2. So where did I get 2? It's from the power of t. Okay, your ft is equals to sine 2t. So Laplace of sine 2t will give you, for this one is your a, isn't it? So you will have 2 over s squared plus 4. Okay, so the next step, substitute into your formula will give you, so this is Laplace of sine 2t. What you want to find is Laplace of t squared sine 2t. So therefore this one is equals to negative 1 to the power of 2, negative 1 squared d squared ds squared of your fs. Okay, so you need to differentiate this function twice. Okay, so d ds of 2 over s squared plus 4 will give you v u prime minus u v prime over v squared s squared plus 4 the whole thing squared. So expand and simplify the numerator part will give you, so since this one is 0, so 0 times by this function will give you 0. So you will end up with negative 4s over s squared plus 4 squared. Okay, so the next one is differentiate this function. So d ds of negative 4s over s squared plus 4 the whole thing squared will give you, okay, let's say I want to factorize negative. If you want to take the whole function as your u, you can also do that. Okay, so you want me to take this one as a whole function? Okay, let's try. Okay, so you know that your v is equals to s squared plus 4 the whole thing squared, u prime is equals to negative 4 minus u negative 4s, v prime is equals to, so how are you going to differentiate this one, this function? So bring the power to the front, so you will have 2 s squared plus 4, so now the power is reduced to 1, isn't it? And the last part is to differentiate inside here will give you 2s over s squared plus 4 the whole thing power 4. Okay, so here you have lots of way to simplify this function. Okay, as long as you are trying to simplify, okay, then it's okay. Okay, let's say I want to factorize the same function, okay, the similar terms of function. So as you can see here, you have x squared plus 4, here you have x squared plus 4, and for the denominator parts you also have x squared plus 4. So for the numerator part, I'm going to factorize s squared plus 4. So why I'm just choosing power 1 not squared, because for this part you just have a single term of s squared plus 4. Okay, so we take the least one. Okay, so factorize s squared plus 4 will give you, so what is left in the numerator part, so negative 4 times this one s squared plus 4, because here you have squared, so you already factorized one, so you left another one here. Okay, remember when you expand this one back, you should get this function. Okay, so for you to check your answer, for you to check your answer, so just try to expand the function again and make sure that when you expand again the function, you get the same function as before. Okay, so for this part, since you already factorized s squared plus 4, so you left with the rest of it. 2s times 2, you will have 4s. 4s, so this is minus minus will give you plus. 4 times 4 will give you 16 s squared. Okay, over s squared plus 4 power 4. So you can cancel out this one, so left with 3. Okay, so simplify. The numerator part here will give you, so 16s squared minus 4s squared, so you will have 12s squared minus 16 over s squared plus 4 cube. Okay, so since you already differentiate the function twice, so this is the first one, this is the second one. Okay, so now take this function, substitute back into here. Okay, so therefore Laplace of t squared sine 2t is equals to negative 1 squared times the function that you get, this one, 12s squared minus 16 over s squared plus 4 cube. If you have an even function for n, so it does not affect anything. Okay, if you have an odd here, let's say negative 1 power 1 power 3, so you have to expand for the numerator part. Okay, so this one end up with 12s squared minus 16 over s squared plus 4 cube. Okay, so basically we are just repeating the same steps. The first one is identify your n. How to get your n? Refer to the power of t. Okay, the next one is find your fs from your ft. How to get your ft? The other function other than t to the power of n, that is your ft. Okay, so get the Laplace of your ft first, this one here, and substitute into the formula, because what you find in the table of Laplace is sine 2t. If you notice that, why we apply properties of Laplace transform, because you cannot get this Laplace transform of this function by using table of Laplace transform. Okay, that's why you need to apply properties of the Laplace transform. Okay, so this one here you need to apply differentiation. So how many times you need to differentiate? It depends on your n. Since your n is equals to 2, so you have to differentiate twice. So the first differentiation give you this answer. So the next one, differentiate this one, will give you this answer. Okay, so when you have this one, substitute back into the formula and times by this one, so you will have your final answer. Okay, so basically we are done with the properties of the Laplace transform. Okay, so I just summarize here. We apply properties when we cannot get the Laplace transform of that function directly from the table of the Laplace transform. So if you have a function that you cannot solve, that you cannot find directly from the table of the Laplace transform, then these three properties must come to your mind. So either you have to use linearity, first shift, or multiplying by Tn function. Okay, so when to apply linearity properties? When you have more than one function, so you need to separate the function. Okay, you factorize the constant and separate the function plus minus. Okay, linearity is for plus minus function. Okay, when you have a multiplication of two functions, so it's either you are using first shift or multiplying by Tn. So take a look at the general of first shift. What is the function that you need to have in your first shift properties for you to use that properties, and what is the function that you need to have if you want to apply multiplying by Tn function. Okay, so basically we are done with the first part, which is from ft to fs. So you are applying Laplace transform. Okay, so now what we are learning is we transform from ft to fs by using Laplace operator here. Okay, so in my next video we will take a look on how from this one to get back this function ft. So you need to apply inverse of Laplace transform. If you don't really understand the first part of this one, which is from ft to fs, so you might have a problem when you are going to learn from fs to get your ft. Okay, so please make sure you go through to all my videos and understand it before you proceed to the inverse Laplace transform. Okay, when we are done with the inverse Laplace transform, then only you can solve first order or second order problem. Okay, so I shall see you guys in my next video for inverse of Laplace transform. Thank you. Assalamualaikum. Bye.